Now let's get started with the first topic, eigenvalues and eigenvectors. So before knowing what exactly eigenvalues and eigenvectors are, let's know what a square matrix is. So a matrix with m number of rows and n number of columns and both number of rows and number of columns are equal is known as square matrix. That is a of a inverse, it is equals to a inverse into a is equals to I is identity matrix, and determinant of a shouldn't be equal to 0. So as you know, this is a condition for that finding eigenvalues and eigenvector, and also we can only find eigenvalues and eigenvector of a square matrix. If the matrix is not a square matrix, then we cannot find the eigenvalue and eigenvector. Eigenvalue for a given square matrix lambda is any non-zero scalar real number a minus lambda equals to 0 or determinant of a minus lambda equals to 0. So what this statement mean? The statement mean that for every square matrix we have one variable which is called lambda, and it's non-zero and it's scalar and it's a real number, and we can write a minus lambda equals to 0. A, you know, it's a matrix, given square matrix. Lambda, you know, it's eigenvalue. I is known identity matrix, and determinant of this thing is equals to 0. This is the condition. Keep that in mind. It will be useful for like solving question. This is the starting of solving any question related with matrices. So coming to this characteristic equation, the thing which you see here is nothing but characteristic equation. This thing will not be clear now. It will get cleared after I will explain one question. So when we will solve the equation, this equation means that characteristic equation will get some value for lambda, and that value is called eigenvalue. Okay, so a minus lambda equals to 0. Let x be any vector, that is x equals to x1, x2 till xn, and its row and column is n cross 1. So ax is equals to lambda x, and if we shift it to LHS side, a minus lambda a taking x common equals to 0. A is a matrix, lambda is your eigenvalue, I is identity matrix, and x is eigenvector. Please keep this formula, note this formula. We will be using this formula. Okay, so let's understand eigenvalue and eigenvector through one example. I'll first show 2 cross 2 matrix example, and then I'll show 3 cross 3 matrix example. So the first example, in which the given matrix is 5, 4, 1 and 2, and we need to find the eigenvalue and eigenvector for this matrix. So we can write a minus lambda I, as I have told you earlier, is equals to 0. So a minus lambda into identity matrix equals to 0. Computing this, we get this 5 minus lambda, 4, 1, 2 minus lambda. You will get minus lambda terms only in this diagonal element, not in this. Okay, keep this in mind. Equals to 0. So now cross multiplying this, after cross multiplying you get this equation. This is quadratic equation, and this equation is only called your characteristic equation. You remember I have told you will understand through an example. So this is the characteristic equation. Now finding its root, you get lambda equals to 1 and 6, and this 1 and 6 is nothing but your eigenvalue. Now we will find the eigenvector using this eigenvalue. So we will get one eigenvector corresponding to value lambda equals to 1, and get another eigenvector corresponding to lambda equals to 6. So first we'll take lambda equals to 1 and we substitute. We write a minus lambda into x equals to 0. This is your a minus lambda, you have computed it earlier. X is eigenvector, x1, x2 equals to 0. Now put lambda equals to 1. This you get 4, 4, 1, 1, x1, x2 equals to 0. Now get this two equation, solving this two equation, get 1 and minus 1. So this 1 and minus 1 is your eigenvector corresponding to lambda equals to 1. Now we have to do the same process for lambda equals to 6. So lambda equals to 6, you substitute lambda equals to 6 into this thing, and we get some values. We write the equation. Now we get 4 and 1 solving those two equations. This is eigenvalue corresponding to eigenvector 6, x2, 4 and 1. So this is the way to compute eigenvalue and eigenfunction. Usually in exam you will hardly get 2 into 2 matrix, you will get 3 by 3 matrix. I'll show you how to do that as well. This is just a note that A equals A n cross n, where n is eigenvalue and this is eigenvector n. It means that whatever will be the order of A, that is n here, that will be the eigenvalue and eigenvector. So as you have seen in the previous example, it was 2 cross 2 matrix. So we get lambda value, we get 2 lambda value, and also we get 2 eigenvector. So this is the meaning. Now coming to 3 cross 3 matrix. So A equals to 1 1 3 1 5 1 3 1 1, and we need to again do the same thing, find eigenvalue and eigenvector. So this is the thing, but it's a symmetric matrix. So A equals to A transpose. A minus lambda equals to 0. You know how to do this. Okay, now you expand this determinant. You know how to expand this determinant, you have read in your earlier classes. So do that. You get this equation. This is your characteristic equation. Through this equation you get 3 value of lambda, minus 2, 3 and 6. Now corresponding to each value of lambda you will find eigenvector. First we take lambda equals to minus 2. Substituting minus 2 in place of lambda, x1, x2, x3 is the eigenvector corresponding to lambda equals to minus 2. We get these 3 equations. Now you can apply any rule for solving these 3 equations, not necessarily cross multiplication. You can go with just find the value of x1, x2 and x3. You will get something like this, minus 1, 0 and 1. Repeat the same process for lambda equals to 3, you will get this, and lambda equals to 6, you will get x3 as this. So now our question is done. So this is the way. Now I would like to point one question for the repeated eigenvalues. Like there come a condition in which we get repeated eigenvalues for the provided matrix, and in that case the process is same, but there is a certain way of doing. I'll tell you, don't worry. Suppose this is a matrix 9 1 1 1 9 1 1 1 9. A minus lambda I equals to 0. Getting this, we get lambda equals to 8 8 11. You see, we get repeated eigenvalues. So now for lambda equals to 8, substitute this lambda 8 in this. You get this x1, x2, x3 are your corresponding eigenvector, and now perform the row operations such that any 2 rows become 0. Like keep this point in mind that you have to anyhow perform the row operation to make the any 2 columns 0. Why I am telling you to do this? Because it will simplify our problem, and it is a way of doing for the repeated roots. So I have performed this row operation, these two, and I get both the rows 0. I am only left with this row. So I'll get x1 plus x2 plus x3 equals to 0. Now now say suppose x3 be 1 and x2 be minus 1, and now we will put this value in this equation. We get x1 as 0. So after making one row 0, we can assume any variable value for the given eigenvalue, and we can substitute that value, that variable which we have taken, and we can express the rest of the variable in that term. I hope you people got my point. So now after this, finding the value, now put lambda equals to 11 and find out the corresponding eigenvector for lambda equals to 11. You get 1, 1 and 1. I would like to point out one thing. As we got 0, minus 1 and 1, we can write this in this order also. 0, minus 1, 1 or 0. I have written it 2 times because you know that we got like 2 value, but you can because we know that eigenvector is nothing but the ratio, so you can write it as minus 1 and then 1, and 1 or minus 1 will not make a difference, so keep that in mind. Now we are done with this topic, like this topic eigenvalues and eigenvector, because for this topic we have seen 2 by 2 matrix, 3 by 3 matrix and the repeated value thing. We'll start with next topic.